Okay, so in this problem we're asked, or told here, this is actually data I just grabbed right off of Google, that the mean height of women in the United States is 64.5 inches. That would be 5 feet 4.5 inches. What that means is 50% of women in the U.S. are taller than 5 feet 4.5 inches, and 50% are shorter than 5 feet 4.5 inches. The standard deviation is 2.5 inches. Okay. So let's first ask a question here. Uh, what percent of women are shorter than 69.5 inches? 69.5 inches, or 5 foot 9.5 inches. So what percent of women are shorter than 69.5 inches? Again, we can throw out any height here. I just happened to pick that height, 69.5 inches. Okay. So what we would do here is since we're dealing with shorter, uh, what we're actually, well, I guess let me not get ahead of myself. First thing we're going to do is compute our z-score, and then we'll address the shorter problem here in a minute. So z-score is always our data value minus our mean, and then divided by the standard deviation. Okay, so when we do that, we're going to get 16.5 minus 64 would be 5, divided by 2.5. We're going to have simply a standard deviation of 2. Okay, so that's exactly 269.5 is exactly 2 standard deviations above the mean. Then what we're going to do is look up that value in the chart. So we're going to look up z equals 2 in the chart. Look up z equals 2 in the chart. So let's go up and do that. I have my chart right up above me. And I'm going to find a z value of 2. So there it is, z equals 2. And I look at my percentage there. From the chart I get 97.72. 97.72 in the chart for a z value of 2. So I take that data value down. I'm going to write that down, 97.72. So that gives me a z value of 97.72% from that chart. That's our z value for z equals 2 there, 97.72. Now, the chart that we have there is based on the percent below. That's what the chart always tells us. So since shorter means below that, well, that's exactly what we want. Since it's below, right, that's exactly what we want. The z value below 2. Right, so the chart's actually giving us exactly what we want here. So with below, we just take that value, and that's actually going to be our answer. 97.72% of women are shorter than 5 feet 9.5 inches. So then we just answer that question. 97.72% are below, or shorter in this case, than 5 feet 9.5 inches. Right. So if it's shorter or below, as is the case here, then once we've computed that z-score, we look it up in the chart, and then we're done. We don't have to go any further. Okay, but if we're looking at a different situation where we're asking about the percent above or the percent that are in between two values, then there's a little bit more work that we still have to do. So let's move on to a second question. What percent are taller than 5 feet. Now, that 5 feet, we're going to have to, before we compute anything, we're going to have to convert that over to inches. So there's 60 inches in a foot, or 12 inches in a foot, so there's 60 inches in 5 feet. So 5 feet would be 60 inches, and that's our data value. So we're going to take that first, just like we did before, and compute the z-score. So that's going to be our data value minus our mean divided by the standard deviation. So we work that out. That's going to be negative 4.5 divided by 2.5, and then it's just a calculator computation. Negative 4.5 divided by 2.5, we actually get negative 1.8. Negative 1.8. So we want a percent that are taller than 5 foot, so 5 foot corresponds to 60 inches. 60 inches corresponds to a z-score of negative 1.8. So the next step is we go up to our chart and look up a z-value of negative 1.8. So I'm going to do that. And, oh, no, I'm the wrong one here. Z-value of negative 1.8, there it is. Negative 1.8, and we see that negative 1.8 corresponds to 3.59. 3.59. So we come back down here, and we know that our chart leads us to a 3.59. Our chart leads us to 3.59%. But remember, the chart tells us the percent below. So if we were looking at our picture here, right, and this was our z-value of negative 1.8, the chart's telling us that there is 3.59% are below that. But that's not what we want. We want this amount here, this percent above. We want percent above. So what we have to do here when we are dealing with the percent above, the chart's always going to tell us below, right? But we want in this case above, higher than. So what we have to do is realize the whole picture is 100%. The whole picture is 100%. So to get the percent above, what we have to do is take 100% and subtract off that answer. So 100% minus 3.59. Now we find out that 96.41% of women are above 5 foot tall. Okay. Most women are taller than 5 feet. So that's if we're dealing with above. Below, again, as we saw, we just take the chart value and that's it. For above, what we have to do is we take 100% minus the chart value, and that'll tell us the percent that falls above a certain level. Okay, and then there's one other question that we can ask, one other type of question we can ask, and that's the percent that fall between a certain level. That's the percent that fall between a certain level. Okay, so let's take a look at that situation there. So let's ask, what percent of women are between let's say 51 inches and 57 inches. So what we would do first off is for each of our data values, what we would do is compute the z-score for each one. So that's going to be the first thing in each of these problems, is computing the z-score for each one. So let's do that. So for 51 inches, it would be 51 minus our mean, 54.5 inches, divided by our standard deviation of 2.5. Okay, 2.5. So once again, it's just a simple calculator problem. 51 minus 54.5 divided by 2.5. And so we get a z-score of negative 1.4. Okay. And then we do the same thing for the 57. So 57 minus 54.5 divided by 2.5. And that's just going to come out to be exactly 1. Then what we're going to do for both of those data values is we're going to take and look those values up in the chart. We're going to take those values and we're now going to look them up in the chart. So we're going to go up to our chart here. We have a negative 1.4 is our first one. So negative 1.4 in my chart corresponds to 8.08%. So let me mark that down here. 8.08% are below that level. This chart is always below. Then I'll look up a z-score of 1. So here it is. Z-score of 1 corresponds to 84.13%. 84.13%. So mark that down as well. 84.13%. So one thing I can say right now, 84% of women are 57 inches or shorter. Okay, fall below 57 inches. Okay. And now we want the amount that are in between these two amounts. So what you have to understand here is if I was to draw the distribution here, my first data value, 8% fall down here. Okay, fall between underneath that one. And then my second data value here, 84% is all the way down to here. All the way down. But we just want what's in between the two. We just want what's in between the two. So what we actually have to do is just take those two answers and we subtract them. And that will get us the percent between. Take the high one minus the low one. And that will give us the percent that fall between. So it turns out 76.05, 76.05% between. So about 3/4 of all women in the United States anyway fall between 51 and 57 inches. About 3/4. About 3/4. Now, as you know, time goes on, these numbers change. This average changes. You could go back and go online and look at the average height in 1920, and we're going to find it's probably going to be shorter, uh, and of course across other times as well. Right? And those are based on a lot of different factors. One being nutrition, uh, probably being one of the bigger factors. Okay, and so that is what we have here. That is what we have here uh, with these problems. So just to kind of recap again, if we're looking at the percent below, then we quite simply just take the chart value. So every problem, we're taking our data value, computing the z-score for that data value, and then looking it up in the chart. And then what we do depends on the problem. If we're looking for below, then we just take the chart value. If we're looking for above, right, then we're going to take 100% minus the chart value. And if we're looking for between, we're going to take our two values from the chart and subtract the two. The first step is very important. You compute the z-score first.